All right, number 9, we want to solve for y. We have x equals 7 minus y over y plus 5. So now this looks a little bit more complex because we have 2 y's in the problem. Usually when that happens, we're going to want to get them on the same side, and then we'll factor out the y. So since we have a fraction, I want to multiply by the denominator to get that out of the denominator. Okay, and so over here, this will give me, distribute that x, this will give me x times y plus 5x equals, that will divide out on the bottom, 7 minus y. Alright, so now I'm going to add the y and move it to this side. I'm also going to move the 5x because I want the 2 terms with the y on the same side. So I'm going to add y, and I'm going to subtract 5x. Alright, so what happens? Positive y, negative y, 0 out. Positive 5, negative 5x, 0 out. Bring down the xy plus y, separate terms, equals, bring down the 7, and then the minus 5x. Okay, so now I got both terms with y on the same side. I'm going to factor out the y. It's going to leave me with x. Y divided by y is 1, and that equals 7 minus 5x, and then last thing, we're going to divide by the x plus 1 to get y by itself. And then ultimately we're left with y equals 7 minus 5x over x plus 1. Number 10, we want to determine if the relation defines y as a function of x. Okay, so when you talk about a graph being a function, it has to pass what we call a vertical line test. So if you have a function like this and we draw a vertical line, it should only cross one time, no matter where you draw that vertical line. Okay. If you have a function and it crosses twice, it's not a function, okay? Because you have 2 x values going to the same y value. So with this picture, if we were to draw a vertical line, there are some spots where it will hit the line more than once. So we will say no, this does not define y as a function of x.